Now in this video we're just going to be looking at non-linear graphs, how to recognise them, some of their features. We're going to look at four in particular. First one is quadratics. Quadratic is just the shape like that. Parabolic shape. So they can be more narrow, they can stretch down, they can be moved across to the side. That particular shape, they can be flipped over. So they're called a quadratic. They have the general shape. There's a couple of general forms of a quadratic, but at the moment the one we're going to look at is form of y is equal to, well, the original one that I drew, y here like that, that's y is equal to x squared. I can put any sort of number I want in front of it. It could be 2x squared, 3x squared, so let's put some letter a there. So then I can add some, instead of an x squared term, I can add an x term to it with any particular coefficient in front of it, and then some particular constant on the end. So this is what we call the general form of a quadratic equation. Y equals ax squared plus bx plus c. For example, y is equal to 3x squared minus 2x plus 1, for example, would be a quadratic. And you're going to learn in future videos the a, in this case a is equal to 3, the b, which is equal to -2, and the c, which is equal to +1. They all have different jobs. They do different things to make the graph move around and change its shape. But just for now, all you need to do is recognise this curved parabolic shape. We call it a quadratic. Now, next one you're going to be looking at is a circle. Now, two general forms of a circle, very, very similar. Now, if I had a circle here, and I made it centre there at the origin, 0, 0, and I came out a radius to there. Well, that was the radius, and the same distance up there, same distance there, same distance there. So there's my circle. Its general form is this: x squared plus y squared is equal to whatever the radius is, squared. So on this particular one, if the radius was 3, it came out to 3 there, 3 there, -3, -3. This equation would be x squared plus y squared is equal to, radius is 3, 3 squared is 9. So that would be the general form of a circle centre of the origin. Let's say I had this particular one. X minus 2 squared plus y plus 3 squared is equal to 16. This is also a circle. Now, first of all, its location of its centre. Now, I've got -2 in here, so I take the negative of that number. The negative of that would be +2, so I go +2 in the x direction. Take the negative of that number, -3 in the y direction. There's the centre of the circle at 2, -3, which I get from here. Then its radius, once again, it's still going to be radius squared is equal to 16, so the radius is going to be equal to 4. So I get 4 units either way. And there somewhere. Badly drawn circle, I know, but there it is. So this is the general form of a circle centre of the origin, and for general form of a circle centre anywhere else other than the origin is going to be x minus h squared plus y minus k squared is going to be equal to r squared, where r is the radius. And that gives me a circle where the centre is the coordinates +h, +k. So far, there's two non-linear type graphs you need to be familiar with their general shape and their general equation. Now, the third non-linear graph you need to know about is exponentials. They look like this. And there's our axes, and so it grows something like that. And that was in the form of y was equal to, say, 2 to the power of x. So this time your unknown is up there in the index line. various other ones. You could draw other ones that are shaped like this. If I made it y, it was equal to 3 to the power of x. It's more steep. If I made it 4 to the power of x, more steep again. But notice a couple of things here. All of the graphs are going through the same point on the y-axis. In class, I want you to be able to work out what that particular point is. It will always be the same, never changes. See if you can work it out, and more specifically, why it's always that point. And secondly, it's badly drawn here, but each of these lines get closer and closer to the x-axis, but never touch it. We say that the x-axis is an asymptote. The line is asymptotic to the x-axis, gets closer and closer, never touches. So once again, when you get to class, see if you can work out why you think the x-axis is an asymptote. Now, you can do this, change this around a little bit. You don't have to have the x-axis as an asymptote. If you had this, for example, to the power of x, I added 1 to it. That positive 1 takes every single point on the original curve, shifts it up one place. So if that was the original to the power of x, everything now shifts up one place to become this, where that 1 on the y-axis is now the asymptote. It's ever closer to that, but never touches it. And of course, you're now able to work out what that particular point on the y-axis is as well. And then finally, the last type of nonlinear graph that we're going to be looking at is these ones called rectangular hyperbola. They're your 1 over x graphs. So a set of axes, because you're dividing through by x, x is not allowed to be 0. A division by 0 is not allowed. 1 divided by 0 is it's not defined. There is no answer to it. So when x equals 0, the graph doesn't exist. This graph is actually shaped like that. There's values in the positive quadrant up here and the negative quadrant down there. So it's one of these ones where your two variables, x and y, as one value gets bigger, the other value gets smaller. So you can see here, when x is a very small number, y is very large, and as x gets bigger and bigger and bigger, y gets smaller and smaller and smaller. Now we can move that shape around as well. Another general form that you need to know with the hyperbola, as well as that one, is this. Instead of having 1 on the top, you can have any number you want on the top. 2, 10, -4, it makes no difference. So down here, if I divide through by x minus h, that moves it around. So instead of it being non-existent at x equals 0, it's now going to be non-existent where x is h. So that now becomes our asymptotic line. And once again in class, you can work out why in particular. If h is negative here, it's a positive shift there. It's a good little investigation to look at. And then, just as before, if you add a number on the end, it shifts the entire graph up or down. So if I now add k on the end there, so there'll be some value on the y-axis k that where the asymptote is. So the graph is now located here. So rectangular hyperbole, there's your two general forms you need to know about. One's just a variation of the other. So 4 graphs, 4 nonlinear shapes. So you've got quadratics, circles, exponentials, the rectangular hyperbola, all have a general shape to them and a general, you just need to be able to spot them and recognize them at the moment. And we'll do some more work on these in class very soon.